Hello my friends, I am Sharky, and today's video is going to be an introduction to my LDMOS pallet kit. I just finished these up. They are about ready to go out. This is the air-cooled version. This is the water-cooled version. I decided to do both because, you know, water-cooled's not for everybody and air-cooled's just not cool enough for everybody. So this is the final PCB with all the nice cool coloring and lettering and all that stuff. The nice labels on it. This is my older version of the PCB, and for all intents and purposes, it's the same thing. It's just not as snazzy. And the water cooling kit does come with the newer version of the PCB. So this is just here, kind of for demo purposes. This is the air-cooled version. Just a side note, it does not come with most of the connectors, coax, power connectors, coax, these little banana jacks. This right here doesn't come with those things, doesn't come with a heatsink. It's just the pallet kit, does come with a heat spreader. Comes with all of this circuitry, and we'll take a look at exactly what it comes with here in a minute. Water cooled is going to be exactly the same circuit boards and electronics as this pallet. So the electronics are the same between the air and the water cooled, no difference. The big difference is instead of having a heat spreader that's designed to be mounted to a heatsink, this one comes with a water block. So if you've seen my previous videos, you've seen the inside of this water block. It's a pretty cool little gizmo. And there's a few other really subtle differences between the two pallet kits, but that's the main one. One of them comes with a heat spreader, the other one comes with a water block. That's about it. These pallets are good for up to 2 kilowatts output, and they are only good for 27 megahertz. So these are 27 megahertz only pallets. They are not broadbanded. So 27 megahertz plus or minus maybe 500 kilohertz. You know, that's about what it is. You could probably get a little bit more outside of that range, but don't go too far because I don't know what's going to happen. They haven't been tested outside of the 27 megahertz range. That's all on you if you want to experiment with that. So 10 watts of input power will get you 2 kilowatts of output power. These are good for 50 to 65 volts. You can run them lower, but you know, why would you want to do that? They've been tested and they're good for up to 65 volts. If you want to push that limit, you're welcome to, but absolutely no guarantees. These pallets are a kit. If you blow them up, well, welcome to the club. With that said, if you put these together correctly, they will work and they will run like a rape date. And they include a low pass filter, so they won't piss off the ham neighbors, if you know what I mean. That's one of the big differences between this version of the pallet and my previous versions. This one has a built-in low pass filter, and it brings the harmonics way down. This is a very, very clean pallet. Oh boy, I'm happy to have this project done. Took me quite a while to get it done, and I'm ready to get back to my other projects. I've been spending all my time on this. But let's take a look at the air-cooled pallet. So we'll take a look at the air-cooled first, and then everything that comes with it, and then we'll take a look at the water-cooled pallet afterwards. All right. So we've obviously got a couple pieces of wire, one for our input circuit and one for our output circuit. Transformer, input side PCB, output PCB, a few bags of the various components that you need. It does come with a FET. So prices for this pallet are going to be down in the description if you're wondering. It does come with an MRFX 1K80H LDMOS FET. And on that subject, if you'd like me to solder the FET to the spreader before shipping it out, just let me know and I will do that free of charge. There's also a little teeny tiny surface mount transistor underneath the PCB that may be difficult for some of you guys to solder. I would be happy to do that for you. If you would like me to do that, just let me know. I'll do it for you and I'll ship it out, no charge. Like I said, all you got to do is let me know. And if you would like me to do that, give me a day or two to get it done. It's not going to ship next day. I don't have these things ready, so I got to sit down here and solder it for you. Just, you know, that's all I ask. Just give me a day or two. I'll do it no charge. What else do we got going on in the kit? Ooh, this is one that I'm kind of proud of. We got a drilling template. Hey, how about that? Practical, useful. And my phone ran out of recording space. So I think I was just showing you guys the drilling template. This is exactly what it says. It's a drilling template to help you mark and get your hole locations in the correct spot to mount everything to your heatsink. So on the subject of mounting, this kit includes 2 sets of hardware, one of them being metric, which is this kit, and one of them being standard. So I totally understand if you're not a metric fanboy like moi, and that's why I included the standard screws. So to get this mounted to your heatsink, there's those 4 big screw holes right there, and you have 2 options. You have either the M6 or the 1/4-20s. And same with mounting the PCB to the board. So these little screws here, you've got 2 options. You've got M3s and you've also got 440s. So that is also included in the kit. Right after I post this video, there will be an instructional video on how to assemble the pallet, a complete walkthrough from start to finish, all the way into plugging it in, testing it, and giving it a shot. So let me clean up my desk and we'll take a look at the water cooling pallet. And here are some of the differences between the air-cooled and the water cooling kit. Really the big one is that this one comes with a water block instead of a heat spreader. So that's what she looks like. I don't think I mentioned this on the previous kit, but the only way to mount these FETs is by soldering them. That is by far the best way to do it, and it is the only way to do that. The heat spreader and the water block do not have mounting screw holes to mount your FET down, only a pad for soldering. This is the bottom side of the water block, so if you guys watched my previous video, you had a chance to look inside of here. These threads are BSPP 1/4 inch or 1/4 inch G thread. There's a couple names for them, basically the same thing. And these fit standard personal computer water cooling fittings. So if you guys have never looked into it, the water cooling market for computers is huge. And there's a million different options for fittings and radiators and pumps and hoses, and everything you could imagine for water cooling already exists in the PC world. And it's actually really quite economical. All that stuff's come down in price just because there's so much volume, so many guys building water-cooled PCs. So that's why that's compatible. As far as water parameters for this, I recommend 1 gallon per minute, and I recommend you keep it under 50 degrees Celsius for your water temp. But I don't have my notes handy. I think you can push it a little bit higher. There will be a really nice packet of documentation that goes along with the air-cooled and the water-cooled pallet that gives you details on that stuff. One thing I didn't mention is that the air-cooled spreader comes with a thermometer port for temperature monitoring on the FET. So just like on the water cooling kit, you want to monitor your flow rate and your water temperature. If you keep those in a safe set of parameters, your FET will be fine. With the air cool, you don't have flow rate, you just need to monitor basically the case temperature. And in the back of this heat spreader, there's a thermometer port that goes directly underneath the FET. And all the data for that will be included with the device. I just haven't finished it yet. I'm going to type it up right after this video. Another one of the differences between the water cooling and the air cool kit is that the water cooling kit comes with, I call it a mounting plate, because you can mount the entire pallet to this plate, run your hoses, run your wires, and you'll be good to go. This whole plate, you can mount your pallet up to it, and then you can mount this sacrificial plate into your amplifier. So that's basically what this is. It's just a sacrificial plate that you can drill holes into, and it's really just for convenient mounting. You could even solder this down to another circuit board to hold it in place if you wanted. But it's kind of up to you, however you want to use it. If you want to use it at all, you can. If you want to use it as a drilling template, it will do that as well. It's got the holes marked for the water cooling fittings to mount the water block, to mount the PCB. And this is just a wire in case you want to run a power wire up to the bottom like I did on my, my 4 transistor water-cooled LDMOS project. So other than the spreader, the mounting plate, and a few nuts and bolts, there's some slightly different nuts and bolts that go with this. It's basically the same electronics, same transformer, same FET, all that good stuff. I didn't mention what was in this box. This is this is a couple of coils. So this is this coil here and this coil here. And they come pre-wound, and they're shipped in this box so that they don't get bent out of shape by the time they arrive to you. So yeah, that's the water cooling kit right there. What are we going to do next? What do we got to do next? Let's turn it on and see what it does. We are ready to fire it up. Let me give you a rundown of what we got going on here. Okay, so let's follow our input wire. This is our input RF, and that piece of coax comes over here to a line section. That is a 10-watt slug, and that is being read, if you follow this wire here, this is going over to this bird meter. So this is reading in 10 watts average power, no peak, no multiplier. And our output power is coming from this coax, from this side of the board, right over to this bird meter and line section. And that one is a 2500 watt slug, and it's also stingier by far than any other of my slugs. For some reason this one's particularly stingy, but we'll still get up to 2K. This is also reading an average power, no peak, no multiplier, none of that stuff. Here's our power supply. Let me kick that on. Actually, turn that off first, just to make sure we're not in danger. Okay. So this is our power supply, 65 volts. We're drawing about 200 milliamps of bias current. This meter's not showing that, but it's right around 200 milliamps. And that green wire is coming from the power supply, feeding right into here. These wires here, these two, just for the fan on the heatsink there, and these two are running up to 12 volt bench power supply. That supplies our bias, our gate bias voltage. So that green LED is for the gate bias, and that is for the drain bias. One thing I probably haven't mentioned yet is how I'm going to be driving this. I'm kind of proud of my little setup over here. So if you follow this wire, this is a 3 dB attenuator, and the power going into that is coming from this wire, which is coming from this little tiny driver box up here. So this is actually an LDMOS driver amplifier. It's a little tiny LDMOS chip, MRF 101. It's running on 50 volts, and what it's doing is it's amplifying the signal from my function generator down here. So this is my fancy new function generator, and I am super happy with how it works. So we'll be running at 27.185 megahertz. Pure sine wave, continuous carrier, no AM, no none of that, just continuous carrier, and we're gonna keep it simple like that. So, I think we're all ready to go. Let's hit the button. Bada bing! A little over 10 watts of input power. A little over 10 watts. Drawing about 39 amps. And here is our spectrum. So let me get this set up a little bit better. Where's my button? Trace. Let's go to max hold. Okay, so we're taking a sample at about 2 kilowatts, about 10 watts of input drive. And these are the results that we are getting. So our first harmonic, 60 dB down. Second harmonic, 55 dB down. Third, 64, that's all down in the noise. So as you can see, the carrier first harmonics are... Uh-oh, I messed it up. Our second harmonic is definitely the strongest one that's popping out here. It's still very, very far down. But the first harmonic... Am I messed up? Am I calling the first and the second harmonic? I'm all screwed up. Ignore me. Just look at what you saw on the screen. Here, let's run it again. Alright, let's crank down our bandwidth, get a little bit better noise, trace, max hold. Alright, let's turn that on one more time. Alright, so once again, 2 kilowatts, 10 watts drive. There we go. Okay. I don't know which one's the second and third. Maybe I'm just having a brain fart. This harmonic all the way down to the noise. This harmonic, the strongest one at about 55 dB down, and all the rest of them are way down in the noise. So, that's not bad. I'm pretty proud of that. I think that is more than sufficient and significantly better than just about any other 11 meter amplifier you're going to find. You know, you might find one that's a little bit better, but not by much. So these, that's what the low pass filter's for. It really knocks down those other harmonics. Without the low pass filter, LDMOS tends to generate quite a bit of harmonics compared to other types of transistors, but I digress. Those are the results. You've seen the power meter, power supply. If this is something that interests you, please let me know. My email is mudducksharky@gmail.com. These pallets are only going to be available for people on YouTube. So I'm not going to post these up for sale anywhere else just yet. I might do that in a couple of weeks or a month or something like that. But for now, just hit me up at my email address and we'll get you going. So like I said, if you want me to solder the FET and solder the little tiny transistor, I'll be happy to do that. You just got to let me know. What else is there to say? This pallet's basically the same as all my other pallets that you've seen before. You've seen what the power meter says and how much current's getting drawn and how much drive power and all that good stuff, so you're probably pretty familiar with it. Oh boy, this has been a long time coming, and I am glad that I got this project done. Thank you guys for watching. I am Sharky, and I will be back with another video very soon. In fact, right after this one, I'm going to post a complete assembly video for this pallet. And that's about it. Take care, guys. I'll talk to you later.